Hello everyone, welcome to today's presentation. In this presentation, we are going to look for the perfect square root of numbers. We will begin by reviewing the squares of numbers from 1 to 10. We will also review the square root generated by numbers from 1 to 10. Then, we will determine the square root of numbers using the pairing method by solving 3 quick examples. Let us first start by reviewing the squares of numbers from 1 to 10. These will form the basis of our training today. 1 times 1 equals 1. This implies that 1 squared equals 1. 2 times 2 equals 4. This implies that 2 squared equals 4. 3 times 3 equals 9. This implies that 3 squared equals 9. 4 times 4 equals 16. This implies that 4 squared equals 16. 5 times 5 equals 25. This implies that 5 squared equals 25. 6 times 6 equals 36. This implies that 6 squared equals 36. 7 times 7 equals 49. This implies that 7 squared equals 49. 8 times 8 equals 64. This implies that 8 squared equals 64. 9 times 9 equals 81. This implies that 9 squared equals 81. And then finally, 10 times 10 equals 100, which implies that 10 squared equals 100. I will leave in the description below a link to our full multiplication table presentation for you to review. Now let's find the square roots of numbers generated by the squares of numbers from 1 to 10. However, before we do that, let's first of all introduce the square root symbol and define the components therein. The radical is a symbol that indicates the square root. The radicand is the number whose square root we are calculating. The root is the square root of the radicand. The remainder is the final number of the process to solve the square root. We have t, which is the square of the root, which will be generated step by step as we calculate the square root of the numbers given. The next thing we will review is the square roots of all numbers generated by the squares of 1 to 10. So we begin. The square root of 1 equals 1. This implies that the square root of 1 squared equals 1. The square root of 4 equals 2, which implies that the square root of 2 squared equals 2. The square root of 9 equals 3, which means that the square root of 3 squared equals 3. The square root of 16 equals 4, which means that the square root of 4 squared equals 4. The square root of 25 equals 5, which implies that the square root of 5 squared equals 5. The square root of 36 equals 6, which implies that the square root of 6 squared equals 6. The square root of 49 equals 7, which means that the square root of 7 squared equals 7. The square root of 64 equals 8, which implies that the square root of 8 squared equals 8. The square root of 81 equals 9, which implies that the square root of 9 squared equals 9. Finally, the square root of 100 equals 10, which implies that the square root of 10 squared equals 10. Now, we'll move on to our next step where we will evaluate the square root of large numbers by pairing method. Let's find the square root of 121. To solve this expression, we'll first start by splitting the number into pairs beginning from right to left. So we'll combine 1 and 2 and then mark with an apostrophe the demarcation between the pairs and the remaining number, which in this case is 1. The next step is to find the number whose square is closest to but does not exceed the first group of numbers on the left, which in our case is equal to 1. From our squares table, we know that 1 multiplied by 1 equals 1. This way, the first number of the root is obtained and we place it on the right of the radicand. So, that fits very well. We will square the number and find the difference. So we square 1 multiplied by 1 and find the difference, 1 minus 1, which is equal to 0. The next step is to double the root, which means that we'll have 1 multiplied by 2, which will give us 2. and then drop the next pair to the right. We had paired 2 digits, that is 2 and 1. We need to drop them. So drop 1 and then drop 2. This generates a new number, 21. Then, from the doubled root component, we will need to create a number such that when we place an additional digit on the ones position and multiply by the same digit, we should get a number equal or less than 21. So, from the look of things, we need to add 1 into ones position and then multiply the generated number, which is 21, by 1 to get 21, and then substitute the number into the expression. We will need to arrange the numbers and simplify the equation accordingly. So in our case, we will subtract 21 from 21 and reduce the remainder to 0. Then don't forget to include the added root component digit into the main root section to give us the final square root of the radicand. So in this case, we have 11 as the root. This means that the square root of 121 is equal to 11. Let us look at our second question. We will be expected to find the square root of 3481 using the pairing method. So the first step is to split the radicand into pairs beginning from right to left. In this case, we will separate 8 and 1, then demarcate the split with an apostrophe, and then we have 3 and 4 remaining. Next, we need to find the number whose square is close to or equal to 34. From the summary of the square numbers alluded to in the beginning of today's presentation, the square number that is close to and not more than 34 is 25, given by multiplying 5 by 5. Since if we take 6 multiplied by 6, we would get 36, which is far much bigger than 34. So in this case, we take 5 multiplied by 5 to get 25. We then find the difference between the first two pairs by subtracting 25 from 34 to get a remainder of 9. The next step is to double the root component by multiplying 5 by 2, which gives us 10. We then drop the next pair and then generate a number using the double digits where the new number whose square ends with 1, generating a number equal or close to 981. Two numbers yields a square ending with 1. These are 1 and 9. If we choose 1, we will have 1 multiplied by 1, which will give us 1. If we add that to the ones position at the right side of 10, we get 101 multiplied by 1, which gives us 101, which is far much less than 981. So the remaining other option is to have 9 as the ones digit. We now multiply 109 with 9, which gives us 981. We then subtract 981 from 981, and then the remainder is 0. So remember to carry 9 to your root section, and this implies that the square root of 3481 is equals to 59. Our last example requires us to find the square root of 374,544 using the pairing method. The first step is to split the radicand into pairs beginning from the right to the left. Then search for a number whose square is equal or less than 37. From the multiplication table, we know that the number whose square is close to 37 is 36, raising from multiplying 6 by 6. We then find the difference by subtracting 36 from 37 to get 1 as the remainder. We then double the root by multiplying 6 by 2, which is equal to 12. We then generate a new number by adding an additional number to the ones place, such that if you multiply the new number with the added digit, we get a number close or equal to 145. In this case, we will place 1, since if we place 2, the number will result to 122 multiplied by 2, which in turn yields 244, which is far much greater than 145. So in this case, we'll only have to work with 1, and then we multiply 1 by 121 to get 121. We then find the difference by subtracting 121 from 145 to get 24 as the remainder. Next, we drop the next pair to create 2444. We then double the root component to create 122. We need to find a number such that if we place it in the ones position and then multiply the generated number with it, we get a value that is close to or equal to 2444. So from the look of things, the new number that we need to place is 2, such that if you multiply 1222 by 2, we get 2444. Next, we find the difference between the remainder by subtracting 2444 from 2444, which gives us 0 as the remainder. Now, do not forget to add the number to the root component at the top of the radical to generate 612 as a square root. Finally, this means that the square root of 374,544 is equal to 612. This brings us to the end of our presentation today. We reviewed the squares of numbers from 1 to 10 and also reviewed the square root of squares resulting from numbers between 1 and 10. We also determined the square root of numbers using the pairing method. Remember to subscribe and put on the like button to continue receiving similar revision exercises. Activate the bell button to be notified when we upload our next video. See you next time. Thank you.